off. You don't even have to,
Okay.
you don't even have to take slide the printed circuit board out of the case in order to this solution. So you can take the ends off. You're making no circuit board modifications. Obviously, there's other more elegant ways to do it, but this works, and it absolutely solves the heat problem that I was experiencing. And I have 5 of them now, so I have modified 2 of them in this way, and this has also allowed me in the last day. I have now we have 4 sites that are running Whisper Demon with RX 888s. The top European site, OE9.
Rob, we can start with the call and then we can talk about that. Since
Yeah,
it's already 9:04.
I'm sorry. Yes, of course.
Okay.
Go ahead.
So,
Go ahead.
welcome to the July 30th. No, actually, it's August 1st, 2023 session of TangerineSDR and Hamside Technical Session. My name is Dave, KV0S, and this week I've been reorganizing some in my shack and actually taking care of some health problems with my wife. So that's about it for me. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Things are going fine here, just trying to keep all of the projects going. And I'm back to trying to write another paper. So I'm trying to write this one on medium scale traveling atmospheric disturbances using SuperDarn and amateur radio data. So, and many other things as well. So lots of data sets. Back to net.
Very good. Next on the list is Dave, KD0EAG. Go ahead, Dave.
Well, I would like to speak during the regular open session, but I just say that I've been working on some radio prototype and still schematic stuff, but that's it for me for right now.
Okay, we'll come back to you specifically for that. Next on the list is David McGaw in N1HAC. Go ahead, David.
Good evening, everyone on the net. It's been an interesting day, not the least of which has been getting a couple of my fiddles sound posts righted. One had fallen down completely and one was a little tilted, but hopefully they will play well later this week. I also was able to finally get my RX 888 running. I was beginning to wonder if it was functional, but it's just a matter of speed of processor. Boy, these things need a fast processor. But I finally have a computer that would run it at 1 megabyte bandwidth. But if I jump it up above that, it starts to distort. So I think we're going to need a bigger computer, to coin a phrase. But at least I know that mine's working. I can now start drilling holes and put the external reference components in. And I'm going to set it up with a switch and a connector so that I can easily go between them. But that's encouraging. But it really does show me that, I'm a little puzzled why it needs such a high power processor, in that we've been running essentially 40 mega sample per second on much earlier computers, like 15 years earlier.
David,
and I'm not sure why this one wants such a high bandwidth.
David,
but
I'm not sure that there hasn't been, I can't remember exactly, but I seem to remember having seen some discussion on the original discussion groups or somewhere about people having a problem that stuttering that was similar to what you're describing. I'm not sure, maybe Franco remembers seeing that, but it may be a driver thing or something like that.
Well, I'm using what's purported to be the drivers, and maybe we can discuss this in the
I just
that
seem to
later
remember
part,
that.
but I just thought I'd point
That
that
was
out,
resolved.
and I'm up and running at least at some level. So I guess that's enough from here. Back to Net.
Okay, next on the list, we have Jim, K4BSE. Go ahead, Jim.
Good evening, everyone. It's been a very frustrating week, not for me, Dave Whitten. I've been trying to get my magnetometer up, and he's been very patient, but I have been pestering him an awful lot. Still having a problem somewhere that I don't understand. Sometimes it starts taking data, sometimes it doesn't start taking data. I thought I had it figured out this afternoon late, and I didn't. Rebooted and it wouldn't start again. But we'll get to the bottom of it, and hopefully I won't have to be quite such a thorn in Dave's side from now on. Back to Net, K4BSE.
Well, keep at it, Jim. Next on the list is Rob. AI6 in, that's a mouthful. AI6VN. Go ahead.
Okay. Yes. Okay. You've heard enough from me already, but just as an aside, Dave, I'm running these Triple H using Phil Karn's software, the K9Q,
Yeah.
and I can on a i5 6500. That's sixth generation i5. I can process 130 megasample per second. We're using about 130 probably consumes about 40% of the CPU. So there's something about, I guess you're not running it that way, but whatever software you're running, I think is a problem, nothing inherent in the.
I haven't gotten to that software yet. That would be the next stage.
Yeah.
But last week it sounded like it was in flux, so I held off.
Okay, you done, Rob?
Yeah, I suppose
Okay.
so. We can go on later, but
Yes.
that's been my major focus is
Let
the
me-
heat.
Let me finish the roll call, and then next is Michael, AAAK. Go ahead.
Well, thank you. Greetings to everyone listening. Back to you, Dave.
And I want to, everybody, Michael doesn't talk much, but he has recorded every Open HPSDR and Tangerine SDR session to audio since about 2007. Is that right?
My memory isn't good.
We have those things are all online if you ever want to go back and listen to them. So I just want you to know that this is one thing that Michael does. Anyway, next on the list is Bill Engelkey, AB4EJ. Go ahead, Bill.
Well, thanks, Dave, and hello to everyone. Let's see, as far as what I did related to this project this week, I worked a little bit with Rob Troy at University of Scranton, who's building up a multi-channel system to record digital RF. Maybe it's going to hook it up to a bunch of grapes, I think. And we really had a hard time getting GNU radio and digital RF set up to talk to each other, but we actually had to get some help from Tom McDermott and finally from Ryan Boltz at MIT. But finally, I think he's worked out all the errors. The next thing he's got to do is hook it up to some things. And my crappy AT&T connection, I hope you're copying this,
Yes.
it's really bad. I'm going to go upstairs and get on my new satellite dish from Starlink and finish the rest of the meeting up there, because this AT&T at this time of the night is just a disaster. And I've only got it running on the Wi-Fi, so I can't run my big computer on it yet. I still have to run a cable across put the satellite dish up on top of the roof and run a cable and all this and that. So, but anyway, that's it for me. Back to Net.
Oh, okay. Well, good luck with getting on again. Next on the list, we have Franco, K4VZ. Go ahead, Franco.
Hey, please, Franco, I'm glad I come up right after Bill because I didn't forget about you, Bill. Over the weekend, I wrote a GNU Radio module, 3 module to read directly RTP from Phil Karn, so this way it can be connected directly. You can stream off GNU Radio directly from there.
Very good.
I have all the code that compiles and builds. I'm just finishing up, which probably going to take today, the so-called YAML file for GNU Radio Companion. After that, I'm going to push it on GitHub, and you guys can try to use it, and it should streamline the connection from Canon and QRadio to GNU Radio. That's
So
all for me.
are you putting it on your GitHub or Phil's?
Yeah, right now it's going to be a alpha, not even beta. So I'm counting to, for Bill and whoever wants to try it to make sure it works, because for instance, the output is different kind. I did the GR complex, stream it, interleaved shorts and so on, but I need someone to tell me this is, what we expect and so on. And, stay tuned. It's going to be probably tomorrow, I think, at this point.
Okay. We'll send the information to the list if you of the location.
Yeah, I used most of the fields code from PCMCAT. So just, my job usually to cut and paste code from other people and put it together.
Well,
Not
good.
very original, but it works. I mean, if it works, we're good.
Good. Let's see. Next on the list is Gary, AF8A. Go ahead, Gary.
Good evening, everyone. Just checking in to keep up to date, Dave. Thank you.
Okay. And next on the list, Jay said he didn't have anything to contribute in the chat, so I'm going to take him at his word. Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, everyone. Well, I've ordered some of the parts that Gary, or actually all the parts that Gary specified. And the first ones came in very quickly. Of course, they're the least needed of the parts. The last one to come in looks like it's going to be the hard drive, so pretty well out of business until I get that. Spent a fair amount of time putting together a response to a petition to the FCC of a group that wants to run 20 kilowatt or up to 20 kilowatt high frequency transmitters, setting up some kind of communications for high frequency stock and other investment trading. And I got that posted. Today's the last day to submit it. Got that posted here about noon or so my time. Anyway, that's more than enough. Back to you, Dave.
Okay. Well, next on the list is Jonathan, KC3EY. Go ahead, Jonathan.
Hi, everybody. I had quite a busy week, but very productive. So I'm still working on my 3-channel VLF system. So what I did was I finished up the mechanical mounting of everything inside the enclosure, and I also was able to finish up all the wiring. So what I have the GPS pulse per second going into a GPIO pin on the Raspberry Pi. I also have it going into the one of the channels, input channels on the sound card. I also have some GPIOs wired for an activity LED and a capture indicator LED, a timing indicator LED, a safe shutdown button. I tried everything, and that works nicely. I'm using the same image that I made for the VLF system that's currently running at Nathaniel's house. So I was able to, when I originally connected everything inside the Pi, it didn't boot up. So I had to reseat the SD card and everything else, and it finally booted up. I have to figure out. I think I wired the UART incorrectly because I have because all my systems have a serial port for out of band management. So I have a port for the console port on the Raspberry Pi. This way you could set IP addresses and network information and things like that, and you don't have to guess or set up any automated configuration or any of that. And that doesn't work yet. So I think I have the TX and RX wired backwards. But I also I'm having trouble with the audio injector octo sound card. It won't. It's having trouble detecting the. It's having trouble being detected by the operating system. So I have to figure out why. I don't know if it's a connection issue, or if I perhaps have to increase ever so slightly, about 100 millivolts or so on the 5-volt power supply. I've researched various different things to try. It could be lack of power, could be some sort of electrical connection issue, things like that. So I have to work that out. And the Res SMTX, the Trimble Res SMTX GPS module, I got 2 GPS modules off of eBay for $20 total. They came from China, and by no surprise, one of them seems completely dead. Doesn't output a PPS, doesn't talk over serial. So it's probably dead. It's more than likely dead. They don't really test them. They just kind of pull them from systems that were working or might be working, and then they sell them. So it's the luck of the draw, really. So I'm going to try to see if I can get it to talk with Trimble Visual Timing Studio. If not, I'll just put in the other one, and if that doesn't work, I'll just put in another one. That's no big deal. I had planned on using the Trimble Res 720. That's the multi-frequency receiver, the L1, L2, or the L1, L5 receiver. But they're like $200 each. And I wanted to use it for the one I have. I wanted to use it for another project. They're kind of pricey right now. But that is coming along. I expect to have everything running soon, and testing out the performance of the sound card. And after that, then I'll start working on the H-Field receiver. Lastly, I've been having some discussion with Rob about running Whisper Demon with my VLF system. So the plan is I would filter, or I would take bandwidth around 8.27 kilohertz, blank out any spherics, filter it, and convert it to wave files, and then Whisper Demon will take those wave files, and if there are any transmissions, then it should catch them. So I'm working with Rob to kind of get that working. There's not a lot of FST4W and Whisper transmissions on VLF yet. They're very sporadic. The last that have occurred in March and February, but there was a successful test of FST4W on VLF, and I think FST4W has a lot of potential on VLF. That's all I have right now. Back to the net.
Okay, and next on the list is Majid. Majid, any comments?
Hey everyone. Yeah, first of all, I want to say thank you to Bill for spending time to solve this GNU radio with Rob. This is a big help for us. I appreciate it. In process of getting more familiar with KiCad, that was Dave Witten suggested. I finished my circuit designing. This was a very simple circuit for one of our engineering classes as a line following robot. So on Wednesday, I'm going to debug this and send it to Dave. What else? I did modify this and I add the switch and SMA connector for this. I did some testing with Leo Botner. I tried to feed 27 gigahertz. I'm sorry, 27 megahertz clock, and I'm using the software called SDR console, and this was the original software for this particular, and because I'm using a Windows 10. So I thought if I go through this channel, I might get more familiar with this and find some more characteristic of this. That's it. Back to you.
Okay. Next on the list is Michael Howen, AC0G. Go ahead, Michael.
Good evening, everybody. I got possession of the propagation book yesterday, so I get to read Nathaniel's chapter and everything else in there. I've been having a RX-888 that Dave Witten loaned me running all week, listening to Whisper channels. I wrote a script that will grab the stuff out of each directory that Whisper decoded rather stores and uploads it every 10 minutes, and that seems to have been working pretty well. I'm waiting for a couple of RX-888s coming from China. They still seem to be in an airport someplace and have not yet started flying over here from what I can tell. Back to net.
Well, I am aware there is a typhoon near the south end of the China Islands from Japan, so that may change air traffic for a while, this week at least. Anyway, next on the list is Phil, KA9Q. Go ahead, Phil.
Hello, gang. I've been busy lately working with Rob on RX-888 support and also with the local Radio Sun gang. We're using this to receive multiple National Weather Service radio signs while they're in flight. So I've been busy. Had to tear myself away from it just to get here. I guess I'll reserve my time until later if people have questions about KA9Q radio.
Okay. Next on the list is, we already had Rob, Tom McDermott, N5EG. Go ahead, Tom.
Oh, good evening, Dave. Good evening, everyone in the group. Got the RX-888 hooked up to a Linux box and streaming samples out. And I noticed my case seems to run stone cold when it's streaming at maximum rate. So I got a feeling somehow the heat's in the parts and it's not getting out, but I think Franco and Rob have made headway there. I dug a Raspberry Pi 3B Plus out of the junk box, got it hooked up and the software installed on it just this afternoon. And mostly I'm puzzling, trying to figure out which daemons run on the server and which daemons run on the client, and where you configure, who does what. So that's just probably a learning process. And if I learn it, I'll probably write something up about it. Back to the group.
There's several of us trying to figure those steps out and record the process. So I'll join you on that. Next on the list is Win, AI4MB. Win, I'm sorry I cut you off last time, so welcome
No
back.
problem. I'm just trying to find my footing here. I'm on dialysis 3 days a week, and today I came home and found a heat pump, a mini split heat pump that I'd ordered sitting in my front yard. So I had to tear the box apart and inspect it because they just dumped it off.
Boy.
And I found some what I think is superficial damage, but I took pictures and I'll send it to the manufacturer and see what they think. I'm just trying to keep my head above water here on all the comments. Thank you.
Very good. So I think that brings us to the end of the list, and we're open for discussion, although Dave Whitten requested some time to discuss his work with Oscar's schematics and KiCad. You have any you want to go through that, Dave?
Yeah, I just want, I'll be as fast as I can. There's a number of things I'd like to say. The main thing is I've kind of blundered ahead and started making a kind of a breadboard following some of Oscar's original path in developing this family of radios, trying to go from some of his old schematics combined with some slightly newer ones, and plus some other ideas altogether. And so I'm trying to make something where we can get our hands on raw hardware to really get insight into what's going on with these devices, and understand them better, and also to give us a direction for producing our own and making custom ones that suit specific needs of this group. I want to share, I'll share this screen. Let's see. Come on, good. Yeah. Can you see that?
Yes, that's your mock-up that you had.
That's my mock-up that I'm working on. This is essentially what you see there. I'm sorry that it's not sharper than it is. It's hard to hold the camera still enough. But it's essentially a Cypress developer board. The USB developer board, and I don't know whether you can see my mouse, but
yes.
Okay, well, there's the USB 3 port, and there are 2 rows of 40-pin connectors here that plug into the board underneath it. And virtually everything related to the Cypress functionality is available on this board that we could possibly want, and through those connectors, with the addition of some jumpers and another USB 2 connector and a little debugger that allows you to do debugging of the internal. I think let's see, I can't remember which RTOS it uses, but there's it's the one that I think Microsoft bought up, not sure. Anyhow, it's this section here is all debugger, and it allows you to do step-by-step debugging of code. It does not give you any insight into what's going on over on this side, which is this is a LTC 2208 family. There's a whole list of these, and I have all the wrong ones, of course, but currently I'm using a 14-bit one, but it's plug compatible with the 16. I have one of those. It is, and I'm essentially plugging it in and wiring it directly to the out into the data lines from the Cypress board, which appears to be, after much study, appears to be what these boards, how they were developed themselves. Now I have.
Dave, could you bring that up again for a
Sure.
moment?
Oh yeah, sorry. Just a moment. Yeah, share it again. It's, I'm sorry, it's not a better picture.
Oh, it's quite
It's
clear.
fine.
What is the SMA on the top there?
On the top. Okay, yeah, that is, that's even not even soldered in yet. That is an Adafruit 5351 board that, breakout that there's a lot of different variants available from different sources, but that one has 3 clocks out, one. I was hoping to use it, and this is something I need some advice on. I need 2 clocks probably for various purposes on the board, and I would like to have one in for discipline. And you can't, I'm confused. I believe these use the 5351B chips, which do those things. The A chips seem to be essentially unavailable. They are, I think it's the A's that are designed specifically to have one input as a disciplined input. But it appears from all the designs I can see that it can be done this way somehow as well. And so that's what that is. It's got a couple of little I squared. It also makes the I squared C accessible to actually diddle with settings in that thing.
Is that going to be your sample clock?
That was my intent.
Yeah. So you tie that down to the bottom.
Right.
Encode input, as they're calling it.
Well,
yeah, the B version can be VCO'd.
Can it? That's I got that impression from reading, and but the things I read didn't exactly explain. It just said, "Oh, you can do this." So I appreciate the verification.
Right.
But anyway, so that's it. Right now, there's nothing else there, and I'm deliberately trying to eliminate as much extraneous, stuff that I have to wire up, and use boards where I can and get a reasonable simulation, because there's a good chance these work and not such a good chance that mine do. Now, I also want to put this guy up. Yeah, this, well, actually, yeah, this is, okay, now you should see that. This is actually the schematic, yeah, okay, the schematic of that LTC development board. And these are all the 2208, the ones I'm working with are the 2208 ADDs, which are essentially the same as the HPSDR designs, the Mercuries and the Hermes, I think, back in that, maybe not the Hermes, but they're single channel ADDs from LTC, now Analog Devices. They provide a 20-pin pinout here with all the data lines, and I'm essentially connecting to these data lines, and then using whatever other control signals that need, and counting on the circuitry in here, which this is stuff I don't understand well. Both of these things really appear on the BBRF 103s and the on the RX 888, almost, varying variations in these parameters, but essentially these structures with a transformer and I guess or a balun or something, and some balancing stuff. And this is way above my pay grade on this kind of stuff, but and I probably would love to talk to someone who knows about those things. Also,
Well, the encode input is essentially just a balun. Get a balance feed, which the encoder wants from an unbalanced input. The other one, that's a rather complex thing, but it's mostly just frequency control and also getting a good balanced drive.
well, that's
I'm not
essentially
quite sure why they have two transformers there, but the front part is an interesting frequency network.
Something like this appears on.
I think it's a general low pass filter that you can configure as you will.
Well, there are about a dozen variants of this board. Actually, this little table here describes most of them. And I seem to have succeeded in buying all the wrong ones. But this gives, you can't read it probably on that screen, but it gives the substitution parameters, I think, for some of these components, depending on whether you want to use it from 1 megahertz to 70 megahertz, or at 130, greater than 130 megahertz, or something else between the two. And
well, probably the good thing from your side is that they're all the same digital interface.
Right.
So you get one working, you get them all working.
Right. And I deliberately made this plug, to even though I'm sure that doing that degrades the signals, it buys me a lot in exchange for swappability. And especially, I'm always afraid with these sorts of things of killing them with my little fingers. But so, and there's quickly else here. No. It's fine. Of course, it's covering up.
One thing I'm going to add on this, that the right side of the circuits are digital, the left side, other end of the those transformers are analog.
Right.
The transformers are just for oscillating the analog with the digital.
Yeah. I'm able to puzzle out
there's some isolation. It's also level translation, because you'll see that each one of them is floating or biased. You're trying to hit the input level, DC level of the differential inputs.
Right.
So you get maximum dynamic range on them.
Yeah. And all of these documents will ultimately be available in the GitHub that I'm putting, I'll put this stuff in, but I haven't put this part of the design in there yet. Now, because where did all these things come from? Now this, what have I got here? Okay, this is Oscar's original HF 103, or sometimes referred to as RF 103 design. And as you can see, there's some here on the encode input, and he's got, this is a LTC 6420, which I guess is a little buffer amplifier or something. I don't know.
Yes, that's correct.
Okay, and that doesn't bother me too much, but once you get out here, I'm lost. And especially in this case, this chip is not marked anywhere as to exactly what it is.
I see a DAT-31-SP.
Yeah.
7 right there.
Okay, plus.
I think that's just another amplifier.
Okay.
Oh, it's an attenuator.
It's an oh, that's his
This
attenuator.
programmable
yes.
attenuator.
Yeah, it's a
Okay, well,
programmable attenuator.
Yeah, the programmable attenuator is probably, I assume,
then-
a good feature.
Yeah, so you got the attenuator, then you have a 30 megahertz low pass.
Uh-huh.
Then you have the driver amplifier that then
Uh-huh.
drives the ADC.
Yeah, and you've got ATT data and ATT clock and ATT LE.
That's the programming for the attenuator.
Okay, good. I had no idea. This is the more or less where the Cypress module plugs in, and the data lines on this side of this connector, and then he broke out these GPIOs, and a few of them may be useful. I'm not, because they come out here. Here are the programming for the attenuator, and but I'm wondering if I can't lose some of this stuff, if some of it isn't more than we care about, because this involves too much soldering to suit me. There's anyhow, that's I think that's what's going on, though, is he's breaking this out so he could experiment with it. And we want to know what of that we want to experiment with and what we can do without. He has a 30 megahertz low pass filter here, and this antenna input goes to here. So he's got a low pass and FM notch in here also.
Right, that's for probably another level of the 30 megahertz low pass.
Okay.
Plus, it's got those parallel resonant L6, L7 paralleled with C46, 47 would be notching out the FM band.
Okay, well, in various generations of these schematics, some of these values change a good bit, these and these, and he's experimented with different chips. Various people have experimented with different attenuators, and but this appears to be the ultimate antenna input. Now there's stuff down here I don't completely
That's the clock drive.
That's the clock drive. Okay. And then some good old capacitors. But this board was actually using a 2217, which is a different A to D, but it's not very different. It's not pin compatible, but it's very simple. And then this is power supply stuff up here, by and large. And I'm trying to minimize the amount of that to put on, at least on the hand lash up, but maybe put more of it on a quick turn PCB order if we feel we need it. There's almost nothing on this P1 that we need. So is that okay? Can I go on to the next one?
I would go ahead.
Okay, this is a somewhat later and simplified design, but really more functional, the BBRF1. And again, it's the same 2217 A to D, some different values in here. He's using.
Yeah, he's combined the notches with the low pass filter.
So for all intents and purposes, if I want to do this, I should follow this rather than the initial.
That'd be reasonable. And then he's using basically a CMOS analog switch multiplexer as the attenuator. As a switchable attenuator.
Okay, is that this here, the
correct
DC? Okay.
Those resistors on the left-hand side are the attenuator, and you're switching them in and out.
Now, so the RX888 and perhaps a couple other designs used switchable attenuators that are available as a package from people like Peregrine and another company, I can't remember. And, you know, those in the long run would be things to ponder, what we want, what we need.
For prototyping, you don't have to worry so much about that. We can always put an external attenuator in.
Well, my thinking is that I would like to take out well, all of this, because
Well,
this
let's see, that is,
the R820T.
oh yeah,
That's the Raphael chip.
yeah, for our use, yeah, we're not doing VHF.
Yeah, and it just generates heat.
Yeah, no,
And sometimes
don't
quite a
use that.
bit. I've noticed on, you know, on RTL SDRs and stuff, these sometimes get quite warm. And even on this, I took mine out and ran it and it was quite warm. But all in all, this is much simplified. So I would be inclined to, actually, I'd be inclined to take everything from somewhere in here, almost all of what goes, where it goes analog, you know, and try and use external.
Yeah, you're gonna want
filters.
to, like, you want that, what do they got? DD1. There's the antenna input up in the upper left.
Right.
Then the DD1 is the search, the, you know, the input protector.
Yeah.
You could, as I say, you could just take the attenuator out. We can do that externally.
Right.
For working, just run it into the filter. You are going to want a filter, and if he thinks that's effective, that's fine.
I can't use an external filter board.
You could, but you definitely want to have something keeping out of band stuff out of there.
Okay. But that's what I was hoping to do was somewhere in here, draw a line and do without it, and then do without essentially all of this. And here he's using a 5351 clock. And
Right, that's the sample clock that he's coming in, but he also has the ability to put in just a straight crystal oscillator.
Yeah, he discusses that at some point, you know, where he compared it to straight crystal. And I'm not sure, the gist I got was that the 5351 was, well, I don't know which was better, but.
Well, I think that he was looking to test that, but the crystal generally will be cleaner, but the 5351 is pretty good.
Well, since modular 5351 breakouts are readily available, that's easily done, you know, either way or both.
Right.
No, you don't need a amplifier in front of the A to D.
I don't. Okay.
It's it's just driving it directly. But that's a good question. You know, this one is not supplying an amplifier. It's been simplified in that way.
Yeah.
Actually,
and you'll notice that this circuit is very much the same as the LTC evaluation board.
Yes.
In order of time, this comes first. So this is 17. You see the year on top. The HF 103 is 19, I think, or 2020.
Okay.
So this is the original design.
I see.
Yeah, he started.
Oh, okay. So he added the amplifiers and such.
I thought this was later.
His blog, you'll see that this is the first one he talks about is the BBRF, which is the one was then copied, and then he came out with the HF 103 like 3 years or so later.
That makes sense. So he found that yes, input driver amplifier is desirable.
Okay. Well, the driver amplifier is not hard to. Probably not hard for me to do. It's some of this other stuff.
Right.
But
the one thing about that whole part is layout is critical.
Yeah, and probably quite possibly beyond my, you know, beyond, at least without a lot of help.
Well,
Beyond-
again, the eval board
yeah.
gives you good clue as to what good layout is.
Well, and my intent is to use the eval board as much as I can, and then save till later, you know, dealing with the fine points of all that.
The other thing, Dave, you can ask directly Oscar about the Gerber files and the layout of the HF 103 if you want to do that.
Right, right. And I will do that. I almost wrote him today about some of these points, but I really, before I go to him with it, I want to have my questions at least as clear as I can, because he probably hasn't touched this in a while. And, you know, I don't want to make him dig around figuring out what it is I want to know any more than I absolutely have to. But okay, so is there anything here anyone finds cryptic?
Not I, it's all familiar to what I do.
Okay, and I'm gonna, actually, if I'm not careful here, too many little doodle doddles. All right, and last, I think, where did it go? I thought, yeah, that is that one. Okay, so which, oh, cancel. Where, oh, the one, is it no title? No. I'm sorry. Yeah, here. Okay, and now we get to my my conversion of these things. This is a PDF I've emitted from KiCad or KiCad, however you want to say it. And I've been excerpting, you know, what seem to me critical components, you know, and trying to isolate them into functional blocks. So here's, and then labeling buses and things and using it so that ultimately you can route it. And so essentially this is a Cypress header. This is the ADC demo, LTC 2208 header. This is the IO stuff that remains to be fully grasped. These are the what seem to be power supply related items. This has got a 1.2. I can't remember. I think there's a 1.2 and a 1.5 volt, or 1.2 and a 3.3 volt regulator on there somewhere. And this thing, I can't remember what it is, but it's a good thing and available. I'm also checking on part availability as I go along with this stuff. And so far I'm finding everything that we're looking at. And then this would be a SI 5351 VCO, or, you know, chip, may not be the right term, but or a fixed crystal. And
I don't think you would want to have a actual crystal on the board. You would want to have a TCXO.
Okay, well, all right, that suits me fine.
A crystal is going to be very unstable.
Yeah.
Temperature unstable.
In some variants of this, it seemed to be there was an Epson watch crystal or something that he used. Some peculiar Epson part anyhow.
Right.
Yeah, they make probably a lot of time keeping things, but just something, a decent TCXO. So do you think that having the 5351, but presumably the 5351 can run off its own internal oscillator, or there's a variant.
Well, again, you'd want to feed it from a TCXO because it's internal oscillator. It's not going to be stable.
Yeah, well, that's
what we would want to do.
So
So
part of the difference between the A, B, and C variant.
what you might do is wire it so that you can run the TCXO straight to the sampling input, or run it through the 5351, which would give you the programmability.
Okay. Okay. Well, this is okay. This is the mischief I've been up to for what it's worth. And I'm going to try and remember some of those suggestions. I don't expect to remember them all, but that gives me a lot more to go on.
The other thing I would say is make sure you have, if you run it with the TCXO, it should have a enable input. You want to be able to switch that so that you can turn it on and off and run an external clock in, which is how we would discipline it.
Yeah. Okay. Well, that's certainly high on the list of, of priorities. Now, that's my whole spiel on this bit, but I also wanted to say that this gives us what's probably good if y'all are, to the extent that you're happy with essentially a 30 megahertz bandwidth output, and don't want to try and move more data than that even faster. Now that's surely a challenge enough, but there are things coming out now very quickly. A lot of boards and things like this one that I got today. I took it out of its box. It's my new toy. And it's an Intel 13th generation i5. Kind of is somewhere between it's somewhere between a single board computer and a laptop in capability. This particular one has 32 gigs of LDDR5 memory. It has 2 Thunderbolt 4 outputs at 40 gigabits per second each. It has 2 USB 3.2 version 2 outputs at 10 gigabits per second each. It has 2 2.5 gigabyte Ethernet outputs. It seems to have 4 M.2 connectors on the underside. I thought it was only supposed to have 3, but it has at least 2 that are key M, which are essentially PCIe fed out. And in future, I've been looking at some development that's been going on where people have been saying that some of the PCIe based miniature, like the new Lime SDR, for instance, which is probably not what we need for this purpose, but there's another one called a Mu SDR. And those guys claim that you can, with a little adapter board, you can just plug it into one of these. This is an solid state drive. You just plug the same one you put inside your computer, but you put it in here, and then you can plug it into, I think this one's only Thunderbolt 3, but it's way more speed than, that I wouldn't know what anyone would do with the radio. And it's got a little fan in it and everything. And I think the future of these things, if people want to go further in these directions, is to build M.2 boards, build a radio on an M.2 board that plugs into something like this, with or without a very small FPGA that really only does does the parallel to serial and a few minor things to control, to interface, to serialize the output of the A to D chip, essentially. And once you've got that, you can do, especially with Phil's software, you can do, it looks like you could do almost anything you could think of. Maybe I'm wrong. Maybe there's stuff I don't know, but I don't pretend to be informed on all these subjects.
Just make sure it's sufficiently cooled.
Yeah, well, it does have its own little fan in there, and it kept one of the, you can't see it, but there, see, it's got a little thing. I put, there's a couple of generations of SSDs. Some of them get really hot, and it seemed to do fine with the hot ones. Now you can get ones that are a different kind that's less hot, a lot less hot, but well, I'm not saying that little box, but something of that kind, that would be the destination. These would be pluggable, and different designs could be, easily interchanged for different purposes. Could be something bigger, but instead of some of the other design strategies, that to me seems to be the way to get lots of data in and out of it. You've got Thunderbolt, you've got USB 4, there's lots of USB 4 peripherals out there, but there are very, very few computers that say USB 4, except maybe some Apples. Because I think they have to be certified by the USB-IF or somebody, or Intel or somebody. But anyhow, there's a lot more bandwidth that's a lot easier to move around on that bus.
I'm a little concerned about putting radios inside computers. Awful lot of digital currents floating around.
Well, there's almost nothing inside this box except the little fan and the M.2 connector and possibly one translator chip that connects it to the Thunderbolt signal.
I thought you were talking about putting this inside a computer. You're just
no. I'm thinking that
connector. I got it.
Yeah. See, this lets you set it nicely off to, somewhere with a big fan blowing on it, and
Yeah. Well, that essentially gives you your USB interface.
Yeah, but potentially a lot faster if you're I've never been anyone who really cared a lot about all this speed, but some do, and there are probably good science reasons for wanting to see as much of the spectrum at once as possible as well. So I'm just looking at the picture of how to design things in the future.
Well, one thing that I don't know if we're losing sight of it, but the whole point of putting an FPGA in the way, as the Tangerine has, is to process it and downsample it. So you're not having to transmit as high a data rate to the host processor. Now, if you have the data rate and you want the host to do the processing, that's what we're talking about here.
Well, and you could do that too with a small FPGA, something like a little lattice, somebody who still supports SerDes.
Well, the idea behind the complex FPGA is you can put multiple receivers in them.
I don't, I think what happens is that code never really gets written. It's a nice idea, but programmability.
Well, it either gets written for the FPGA or it gets written in the host processor. But then the host processor has to be particularly fast. And of course, the hosts are getting that fast.
I know this is an ongoing debate, but as far as I can see, the host processor is got way more going for it at this point, especially programmers.
Well, the other part of it is that if you have the receivers in the FPGA, they're not getting interrupted.
So
So well, if the host is able to handle that properly, you can, that's fine. But at least traditionally, we've tried to keep the host away from anything that's has to stay isochronous.
I'm not having that problem. I mean, I'm using the Linux real-time scheduler.
Well, that's good.
The-
Things have
these are the
improved.
These are the things that need to be pondered,
Right.
And it really, an awful lot of the mainstream small FPGAs are just seem to be evaporating, except for maybe Lattice and some Chinese companies. But I don't, God, FPGAs are
But
bad.
you are right. Like with the USRPs we've been using, very few people actually program the FPGA in it, even though it has it. We usually just take the raw data out and process it.
Right. If
the host.
in a way, this Cypress is almost like an ASIC that converts, that serializes the A to D data.
Right.
It can be it's actually a very interesting little board. Has tremendous DMA capabilities and stuff, but it is, but is that what we're trying to do? We can build one of those when the time comes. Anyway, that's my
What are you trying to do?
Well, that's another question, but not for me to answer. My way of looking at it is I want to see how you would do what can be done that somebody might want. And from the science side, I think it's very difficult to say ahead of time anything but I want it all.
Well, that's why general purpose computers are good. They don't have the steep learning curve like FPGAs, and you can decide later what software you want to write for them.
Yeah. And I also think the worse than the FPGAs are not so bad, but the tool chains for the FPGAs are inherently proprietary and come and go like,
Exactly.
The flowers in spring.
Right.
And we really want a little longer timeline than that. Anyhow, that's my whatever, my spiel.
Yeah, I sent you a link. I don't know if you saw it, to Oscar's page about the HF 103.
He's the designer of the original RX 888.
Yeah. So actually, no, he's the designer of the BBRF 103 field, which was 2017. And then the Chinese saw that and they designed the RX 888 based on that. But they put the 2208 because in China that chip cost $10-15 for some reason. I don't know exactly where they come from. Other than that, all the ideas are his. And then in 2020, so 3 years later, he came up with the HF 103, where he got only the HF part. It's a link that I put in the chat about 10 minutes ago.
Okay.
And also there are some pictures of the hardware, the board, so you can see how he was putting together the whole thing.
Yeah, I've read that several times, that link, and that's really what got me going in this direction.
Oh, okay.
But it makes good sense. The 2217 actually is a slightly lower performance A to D, and slightly it's like $10 cheaper or $5 cheaper list, and not enough to matter. But
well, if you look at the prices at Mouser, they're probably similar. But if you go by in China, the 2208, for some reason, they throw it by the
Well, there have been some hints that they're removing them from existing devices.
That's probably why.
Yeah,
And that part, I think, was the reason of the demise of the QSDR, because John Cena sold those clones made in China with the 2208, and he couldn't, sell at the same price. So it was kind of what I think
well,
made the camera,
I think even so, this kind of a radio can be a good bit cheaper than what we were looking at with the Tangerine SDR. By the time you put all the bits together, we can, we can come closer to the original project's, cost goal of keeping it cheap enough to make a lot of them. And the price was just going up and up and up as we kept putting bigger A to Ds and this and that and the other thing. And so if we're able to sufficiently, control the speed of the data stream, or have a data stream that we can deal with a general purpose processors like in Radio D, then it seems like it could lower the overall cost of the system. And I'm also thinking not today, but a year from today, the price may go up. The price may go up, the cost may actually go down, over time, as more competition comes from the high end, and we get more capability in the devices we're talking about. But
I mean, looking at what they use, Dave, there, I think the cost for the Chinese is about $80, $100 to make one of those, and they sell them 150, 160, so they make twice as much money. So,
well, I don't, and this is another thing. This is, some people get a little steamed when we go to all the trouble of designing these things, and someone comes along like what's his name, the RX-888 guy, and takes an open source project and turns it into a commercial thing that he sells, manufactures and sells. And that doesn't bother me at all, because if he can make it cheaper than we can, that's to our, we can use bespoke products direct from the factory for the ones that we really want to make sure have the have the best performance or lifetime. But if I can't think his name, if he can build it cheaper, and that seems to be his business model, he's come out with that Pieberry thing too now, that had vanished for a long time because nobody could get parts. Same guy selling those, that just a plug into a Raspberry Pi, and that doesn't bother me anyhow. If it has the features and the performance, behavior we need.
well, that's a comment.
Yeah.
No, and I have to take my wife to the airport tomorrow morning, so I need to get going here.
Okay.
I'll talk to you next week, guys.
Okay, thanks, Franco.
It would be nice though if they gave credit to the original designers.
Yeah. Hey, Franco. Oh, did Franco take off already? I wanted to ask him a question. Well,
well, yeah,
missed him.
Credit's nice, but my only reservation sometimes, well, that's another topic. But
on that, sort of on that score, what is the difference of a Mark II over the original 888?
Main thing seems to be the A to D.
A better A to D?
Yeah, the LTCA 2208. Plus it has a, well, actually it's more to it than that. I think it's got a variable attenuator as well as a variable gain amplifier.
Well,
yeah, it does have some more features. Now that I think about it, it's documented.
The 888, you mean the 888 versus the 888 Mark II or the?
Correct.
Yeah.
Yeah,
Yeah.
that's what I was saying.
Okay, he uses a
There are some
different
significant
attenuator.
differences that are improvements.
Yeah, but there, actually Oscar wrote a page where he kind of details what those differences are.
Right.
And yeah, it's mostly a different attenuator and a couple of other small but not trivial things.
Unfortunately, it doesn't seem to have updated the thermal design.
No,
Yeah,
no,
indeed.
but that's something we can do something about, if we
Yeah.
make.
That's always a challenge. I've been helping people out with that for a long time.
Yeah, well, you
They
can
don't
go,
seem to think about how do you get the heat from the board to the case. Air doesn't do it.
Yeah.
Has to be an
The case
actual
is
thermal connection.
Case is pretty heavy. I mean, on the outside, I don't think
Right.
it got more than 40 C yesterday when we looked at it with a FLIR.
this DuPont foam, that blue stuff, has gotten real popular in a lot of ways.
Right.
It's
Yeah, the
either-
RTL SDRs use it too.
It's either,
but-
well, and
What
I've
is
got
this stuff?
things from Switzerland that do, everybody's using it these days. And it's
I
made
think
with
is
either
using
3M
it-
or DuPont, I can't remember.
What is it? What is it? Some
You
thermal.
have to use it the right
It's the
way.
thermal foam that it's kind of like gummy.
And
Yeah,
you can just,
The problem here is the foam's being used the wrong way.
it's made by 3M.
The foam has to be placed on the ASIC, and then the metal heatsink has to be pushed against the foam laterally to the part. What that does is it squishes the foam and causes the foam to fill all the gaps between the ASIC and the metal part. If you look at the way the RX 888 is constructed, the board is slid into the case. The top
Right.
is not pushed
Well,
down, it is slid in. So it is not making good thermal contact on both surfaces.
Yeah,
That
the other
hasn't
part
been
is that it's a
compliantly
very
squished.
thick piece. You want as little thickness as possible.
Right, but it also has to be under compression so that
Correct,
it gap
right.
fills. And I think that's the problem with the thermal design on the
Oh,
receiver.
okay. It's
Well,
so, yeah.
It's also,
Okay.
they put a heat sink on, I guess it's the A to D, but the FX3 chip does not have a heat sink on it.
Right.
Nor
And
the
And so-
Raphael
I-
chip.
Right, so that's why I was interested in what Rob had done, because I think if you take the end plates off and you blow air through there, that's the only
Oh.
way you're getting the heat out of some of those
Yeah,
parts,
that's,
because the blue foam's not getting it out.
yeah, except there's no mechanical integrity if you take the end plates off.
Oh, yes.
The board
yeah.
is just floating in there.
Well, it's
It's
that's
slid
why I
in,
say
but-
somebody needs to. It would be great if someone could have fabricate some end plates that would be compatible with. I think that's that's the solution that would work
You
from
can
my
always
perspective.
take your end plates off and drill holes in them.
Well, I just took them off and I plugged them in. I mean, you saw earlier. I showed Phil.
Right.
I think you weren't here.
No, I
Here's-
haven't seen it yet.
Yeah, here. I can show you what I did to mine. I took a let's see if I can. I took a little fan from a Raspberry Pi case, and I took the end plates off, both
Right.
ends.
Yeah.
And put this little fan on, tacked it in with a single screw into the, and this actually is quite solid. This is obviously a hack, but this thing is the case, and I believe, as much as I can tell, everything in it is running at room temperature.
Where's the ADB chip relative to the fan?
This
It's
is
sort of in the middle of the whole board.
Yeah, it's hard for me. I don't have a thermocouple to probe in there, but from what I can tell, there's just no heat on the. I don't see any heat at all.
All
I
right,
don't
all
feel it anywhere. And
Rob, didn't you say that you had the voltage regulators were getting hot next to the
They're hot.
electrolytic capacitor?
Yes.
Could you
the-
put a
the-
heat sink on those as well?
I didn't add anything. I didn't even slide the printed circuit board out of the case. I just put took the plates off and put the fan on the end. And I
Okay.
didn't, and I could, and it changed the case temperature from, 100 degrees Fahrenheit down to 70, and as far.
You mean the package temperature?
Yes, the outer package. I don't have, as I say, I don't have a thermocouple that I can go in and probe what the chips are doing, but
I used a USB fan from a case. So it was not a small fan like what you used, Rob. It was sort of a case fan, also USB. Popped the ends off just like you did. And I've used a little fluke temperature probe. The temperature of the case never gets above 80 degrees centigrade. And I have yet to find a spot inside on the board, no matter what I point the probe at, which is greater than 100 degrees with the fan
Fahrenheit.
blowing.
You mean Fahrenheit? You said
Fahrenheit.
centigrade.
I beg your pardon, Fahrenheit, yes.
Yeah.
So it's
Yeah.
the beauty of that larger fan is it's doing both what Dave was saying, it's blowing on the fins, but it's also blowing through the case as well. So, but again, it's a kludge. It's probably a worse kludge than what you did. But at least it keeps it cool.
I hadn't realized you'd taken the end plates off. That makes a lot of sense.
Yeah. Without
you're probably, well, the other thing is I know the USB chips can get hot, and so we could add a little heatsink to that. Same sort of type you put on a Raspberry Pi chip.
Well, we
Yeah,
can easily measure some of these things in our prototypes too, and see, under load, what does how hot do the Cypress chips get?
The Cypress chip was, of the 4 hot chips inside, well, there are 5, the can of the tuner is hot, but the 4 chips you can see, when I had this board sitting out in the free air, the hottest chips were the 2 linear voltage regulators. By far, and they had electrolytics, metal can electrolytics immediately next to them that were as hot as the chips themselves.
And they have large tabs on this printed circuit board. You could actually cut a little piece of copper and solder to it, add a little more heatsink to them.
You put the fan on it, you don't need to do anything.
Right.
As far as I can tell.
I don't like fans.
I don't like fans either. I don't think you can modify this thing with tacking on heat sinks and putting in even a pad of thermal pad across the whole bottom of this thing. I don't think that's gonna solve the heat problem in this design. This design, I think, is fundamentally flawed from a thermal perspective. The only solution is a fan. That's my opinion. I mean, I'm not an expert on thermal design, but I was, everything I tried with the board.
And I told you earlier how I took the fan out of my QESDR because it was driving me nuts.
Well, that is a cheap fan that's known to wear out. So that's not a.
What needs to be done is a case like they've made for the Raspberry Pis that actually press against the individual chips.
Yeah, that seems to be the key in the good designs I've seen that use that foam. They almost always, this was something, a great revelation about 20 years ago. Apparently IBM has a materials research thing, and they published some papers that made it like in Science or something about how the conformality of, the ability of a heat conducting material to transfer heat away from another object is very much dependent on its ability to conform to the surface texture of what it's attached to.
Well, doesn't that seem kind of obvious?
It does, but this is apparently at the almost atomic scale or something. I don't know, but yes, it seemed obvious, but it was kind of a big deal at the same time. And it was after that this 3M stuff appeared.
Has anybody recovered?
Loaded up with diamond dust or something.
Has anybody recovered a broken
Well, yeah.
RX-888? Any recoveries yet on an RX 888 that's gone bad?
Mine is, the one that I lost, I could never recover it. It appears, I think the evidence suggests that it got the inside got so hot. I think I may have been running it at the time Phil's code defaulted to 133 megahertz. So I think that after running for a week, I think that my guess is that some of the pins on the FX3 melted and we lost contact. So then those pins were ones that were used for to determine the boot mode, so the FX3 isn't broken, but I think it's no longer fully soldered to the printed circuit board, and because of that, it's just no longer. We could actually boot it and load new code into it, but it wouldn't do any DMA transfers. It was dead. So.
Oh, so it would show up on their USB, but it would run.
Yeah, it showed up on the USB. Instead of being a device hex F1, it would show itself as hex BC, which is the ID for some kind of a fingerprint reader or something, that Cypress fingerprint reader. And Phil's code would actually load. It was a boot mode for a fingerprint reader, and Phil's code would load the Franco's driver into that. Is this one? This is the defective one. It would load it in it, at which point it would change its ID to the one we want, the hex F1 ID, and it would identify itself as a 888 and everything, but it would not output data bytes. So it was the evidence suggested that the FX3 was still functional, but its connections to the outside world and his idea of what it was, it got lost. And I think the only theory that it was suggested to me is that the solder balls melt and there's some of them
One
lost
test
contact.
you could do, if you don't mind burning it up more, is to run it and see if the ADD gets hot.
Yeah, I'm going to just send it back, tell them it's defect, and
Yeah.
let them give another one. I don't want to debug their thermal designs, and try to work
Yeah.
around it. I've got 5 good ones here. I know how to keep them cool. I want to go and work on software and real problems instead of trying to debug a fundamentally flawed piece of hardware.
Also say, sorry to interrupt you, Phil, but I would also say, do be cautious handling the boards. If you do take them out of there, say to put in an external clock or discipline or something. My feeling, this is just a personal thing, I always mistrusted the USB 2 high-speed, or whatever they were, the old Cypress USB 2 chips that were on, for instance, in the HBSDR, some of the HBSDR boards. They were good chips, but they didn't, something always made me feel they didn't have a lot of protection. And certainly the A to Ds, I can't imagine, aren't, they give me the creeps handling it, really.
Yeah, well,
Well, there is a
Well, use
warning
proper
message
electrostatic
if you look on the board, there's actually a warning message, a static warning message on the board.
Yeah,
So
this
they're
time of
not
year,
well protected.
I don't think many of us should. I mean, all these things should carry that warning, of course, but
oh no, anyone who's in the heat dome better take precautions.
Well, it's hot here, but it's
The
also
humidity is
definitely humid.
very low.
Yeah.
Look what I just got.
Oh, goody.
I was just going to say, we're talking about, full of contact passive. I bought these cases for the Pies, and they're $12 passive. They touch. They have touch all the warm chips. These things work great on the
That's
Pies.
the thing. Someone needs to develop one of those for the RX 888.
I think if we're developing our own RX 888, I think we should benefit from their, not try to fix their design.
Well, I'm just
Do-
saying
do-
that, I
yeah.
mean, if somebody probably could do a land office business doing a custom case for that.
Hey, anybody in this group that wants to do
But
it, I think it'd be great.
absolutely, if we do our own, we need to do proper thermal design.
Yeah, yeah. So it's anyway, I would love for somebody to design some end plates that, you know, where we could use bigger fans that are more reliable and quieter as an interim solution
No, well, the
until
point
we
being that
have our own.
if you have a sufficiently designed case, you shouldn't need a fan.
That's right. But right now, if you want to go and make measurements and do and run develop code, you've got, I mean, we're not going to have our own design in time for the eclipse, I don't think. So these are, yeah. So these are
Low pass filters.
What's that?
30 megahertz low pass filters. So
Ah.
not things so fast.
Oh, those are, by the way, yes, Phil points out
Whose
that
are
if
those,
you're gonna,
Phil?
Oh, these are just mini circuits, 30
They are
megahertz.
mini,
low pass
okay.
filters.
Yeah, we use a lot of those.
yeah,
They're
there's, by
not
the way,
particularly good, but I'll tell you, if you put two together, they actually get quite good.
well, here's an
I bought two.
alternative.
Right.
If you guys are with the 888s want to run them at 33 at 66 megasamples, here's my friend Paul Elliott, WB6CXC is fabricating a run of these low pass filters.
What's
and
he
these
getting for stop band attenuation on
well,
that?
there's the stop. There's the.
I can't read that.
I know. Let me see if I can blow it up for you. It's pretty much 60 plus dB.
70. Yeah, 65.
Okay.
Minus 65.
Yeah,
that's
so,
pretty good. I've done better.
By the you know, what he was limited by was the characteristics of the surface mount coils that he could get. You know, this is a design that can be entirely fabricated apart from soldering the SMA connectors.
Yep.
This comes fabricated from JL PCB. So, so these are very inexpensive, and he'll have a bunch of them soon. So you can.
That's good.
And so this is
nice.
and of course there's also the internal 66 megahertz low pass filter inside the 888. So the actual stop band attenuation above
true.
66 will be the concatenation of that internal and this external. This also has the option of putting in a high pass shelving filter in. And let's see if I can go down. Here's the green. This is an option, but for most wideband SDRs, you know, you're getting overloaded by not only AM broadcasters, but signals in the shortwave band. So all the SDRs that I run have these shelving filters in them, so that we can and then we add additional gain, put a gain stage, and to compensate for the noise figure of the Kiwi. So in order to the Kiwi, and in fact has a noise figure about 17 dB. So I don't know, 17 dB noise figure, which means that the internal noise at a quiet site like the ones I run, KPH and KFS and my Maui site, those quiet sites, the internal noise of the Kiwi is about 6 or 7 dB above the noise that comes off of the antenna from the ionosphere up at the higher frequency.
That's pretty bad.
Well, that's true of most SDRs, and the 888 is worse than the Kiwi.
Yep.
It's 3 dB worse.
There are plenty of amplifiers out there you can use to.
But once you put when you put the amplifier in, then you compound the problem of overloading. So how do you so you need to address how to deal with overloading in the real world. And this is one of the elements. I mean, every site is unique in terms of the overload
Only
problems.
overload I've ever seen, Rob, is in AM broadcast band. Are you really seeing
Right.
it elsewhere?
And you're you know.
Yeah, and there are plenty of AM broadcast.
There's a lot, a lot of, and of course you can put a blocking filter in, but no, if you don't, if you're running a system 24/7, like I am at those sites, overload events are occurring at times when you're not listening or watching. So you need to log the overload events, which is something my software does. It keeps a log of overload events. How many overload events occurred in each whisper cycle? And that allows you to determine how the validity of
Have
the
you looked
samples.
at those? I mean, are they just nearby thunderstorms? Maybe.
Sometimes, but
nearby hams.
Sometimes it's ham, sometimes it's overload. For some sites, like in the people in the in the East Coast or in Europe, they're shortwave broadcasters.
Yeah, but those are continuous.
So they
mostly continuous.
and it's not continuous. It changes from hour to hour, especially gray line. You'll see overloads in gray line. So I can show you a log at KFS that shows that, you know, that, and so if you're not watching at 4 a.m. and 5 a.m. and 6 a.m. and looking at your SDR, and you want to make measurements at those times, of course, then you don't know that it's happening unless you are continuously monitoring it. And that's one of the things that
if you're interested in just certain bands, you should be using bandpass filters.
Well,
I know what you're talking about, because I was in Greenland one time setting up our equipment, and I was getting this pure 6 megahertz signal coming into our A to D at very high level, practically clipping. And I'm wondering, what in the station is putting out 6 megahertz? Then I took my shortwave radio and tuned to it. It was Radio Havana.
Yeah,
putting out half a megawatt.
Like in Europe, their problem is Radio Romania. They have a half a megawatt transmitter now that's on 41 meter, 39, whatever broadcast band. So every site is unique.
Why would Romania do that? It's not even a very big country.
I don't know. I can't tell you, but my European friends, my European users have to deal with it. There are other for one of my users is the top whisper receiver in the world in the Canary Islands, and he's overwhelmed. He's overwhelmed with 14 meter broadcasts. Overwhelmed him from the coming in from Africa, and he's a few, when especially at the gray line times. So everybody has, those kinds of problems. Really, you have to have you almost have to have cavity tuned filters in order to get rid of those. And so
I'm curious, because my wife is Romanian and I go there periodically. And I would be curious where that's broadcasting from.
Right. You can.
Romania is one of the last shortwave broadcasters on the air, along with Havana, Cuba.
Yeah. Well, I think that BBC and others are turning on their shortwave broadcast stations once again because of the internet interference.
I just discovered a high power broadcaster over in Maine.
Yeah,
at like 6.9 megahertz or something.
Yeah, there is I think a religious station, W something in Florida, that is also a 50,000 watt shortwave.
If it's American on shortwave, it's religious.
Yeah, this was a half a megawatt station over in Maine.
Yeah, well, all of these. So that you have to look at. You need to look at your whole spectrum, and you need to look at it over the whole of a 24-hour period. And that's what I've been. That's the capability that I incorporated into Whisper Daemon.
I am curious what the state of Phil's software is and what we can load up now.
What would you like to know about it?
Well, last week I thought you were saying that it was in flux and don't
Well, it is.
use
I
it
mean,
quite yet.
flux is getting finer and finer as time goes on, but it's working.
Well,
Yeah,
I
and
thought
it-
people were saying something had broken.
No,
so
no,
was-
well, the integration of his software with Whisper Daemon wasn't completed, but it is now completed, and you can download a beta version of Whisper Daemon, and it's version 3.1.0, and it will, if you configure it define a radio whose name starts with K9Q. These are logical radios. Then it will load Phil software and configure it and talk to. Of course, you have to have a 888 there, but it will talk to the 888 and decode. I'm running it at 4 sites right now, including I have one running right here. Now don't have an antenna, but I have it running here, and this is a i5 6500, which
Where is that software available from?
whisperdemon.org. It's on a GitHub site. If you go to whisperdemon.org, there'll
Is
be a
there any
link.
way you can do releases, even, like alpha or beta releases? It's simple to do in GitHub. And
Yes.
just so that there's, something with known, the bugs that are there are known. And those of us who are not tracking it daily could use those. And but
Yeah, it's
tracking
always good to have a beta version and a release version, at least.
Yeah.
My problem, I'm still new to GitHub. I gotta learn how to do it.
It's actually quite simple. It's quite simple to create a tag and make a release version and then those are stored on a separate page with a pointer to them, where a person can download, either source, or if you've been building binaries.
I know SD Radio does that.
Sure, almost everybody does it.
Almost
these days.
everybody has that.
Yeah, but at least
Keep
all
a known good release version.
I
and then
understand how complex it is to
update the
just
beta.
deal with the tools, and GitHub's just one of the tools, but that would be really helpful to some of the rest of us. And if we could have something we could play with, and then when something was broke, we'd be able to ask question, did you know that this version did this? Because y'all are on to something quite else by the time we
Yeah, the problem is in the last couple of weeks, I've been doing this integration between the front end modules and Radio D, which is kind of a major change. That's settling down now. They're all done except for one, and that's the SDR play. So at this point, the main thing you need is documentation. I need to update the documentation pages on how to configure this. It's actually simpler than it was, but it's different. So it needs to be documented.
So what's the problem with SDR Play at this point?
Oh, I just have to do the work. I started with this architecture in which all the front end modules were in a separate program, a separate daemon that multicast their outputs. And that reached a breaking point with the RX 888 because it just wasn't fast enough to carry that kind of data. So I finally said, okay, to hell with this. This really hasn't worked out. I'm just going to merge them all right into Radio D. And that's what I've been doing for the last couple of weeks. I've done the RX 888. I've done the AirSpy, HF, the Fun Cube, and let's see, I just did the RTL SDR last night. See what are the other ones. I think that's it. All that's left is the SDR play. And the integration actually makes things a lot easier to configure.
Yeah, we have a lot of SDR Play receivers. It'd be nice to have that one there.
Yeah, I think it was
Use
Frank
that.
who wrote the SDR play. I have a couple SDR plays, but I've never actually used them myself. So,
Yeah, I've used RSP1A up through the RSPDX now.
Yeah,
and we use a lot of duos because we like the 2-channel part.
Kind of taken a dislike to it because of the proprietary interface. I feel like, well, gee, why should I work my butt off to reverse engineer their stuff when I have alternatives that are not proprietary? I've
got 8 of them plugged in to a server in two servers, one here in KFS and one I've got, almost 24 SDR Play 1As, and
Oh,
they're fragile devices. I'm going to sell them if I can as soon as
well,
we
people
can
have
plug
them, so
in.
I guess people already have them, so I should probably try to make them
Right.
work.
Yeah,
There are a
yeah.
lot of them out there.
Yeah.
The problem I have with RX-888 is it's only one channel. We do
Oh,
a lot of
yeah.
2-channel work.
It's it's a,
Right saddle.
yeah,
How many
yeah,
channels do you want?
what do you mean by one channel?
Yeah.
What do you mean
It's
by
a
one channel?
it's a single channel. It doesn't sample two signals
You
at the same time.
you need a dual ADC. You mean it's not a
Right.
dual? Yeah, yeah.
Oh,
Well, that's
yeah.
Well, that's Phil.
None of the other
Phil.
ones I mentioned do that either.
I see what you're thinking channel, but yeah,
Yeah,
two
that-
inputs, because we do a lot of phase stuff.
Yeah.
Oh,
Well, that's
yeah,
Phase
well,
steering.
no.
None of the other ones I bet should do that yet.
Phil has I think and Glenn N6GN have been discussing a technique that could in which we could, with Phil's software and some additional front end, a little hardware, we might be able to sample synchronize multiple 888s.
Right, that would
but
be a good thing to do. And
That would-
anything I think
yeah.
that we do under,
And-
proprietary, our own work needs to
that-
be able to run multiple channels. In fact, we'd like up to 4, but 2
Well,
is like a minimum for a lot of the
Right.
work we do.
Well, the technique that Phil's described, I think, could extend to N.
Right.
Right. I mean,
Right.
you're yeah. But I think that would be a circuit that should be included in the Tangerine design.
Yes,
Is the ability to inject that stimulus into the sampling input, so that there could be synchronization between multiple. So
Right.
that would be a feature that would distinguish this Tangerine design from the 888.
Right.
So I was just going to show you guys it just briefly. This is a little $100 Think Center i5 6500 running the 888 at 130 megasamples per second. And you can see the top is a strip chart of showing the CPU utilization. So this is this is about 20-30% busy doing its ingesting the samples and performing the FFTs and demodulating those two. I have about 20 demodulated audio output streams coming out of Phil's from Phil's K9Q radio service, the radio DEAM. So this gives you an idea of how efficient Phil's software is at processing. I don't need to run this thing. Now that it's cooled, I don't mind running at 130 megasamples. But prior to this, I was turning it down. But there isn't the CPU utilization went from to 22% to 29% when I doubled the sample rate.
Looks like
anyway,
you're not even running the real-time kernel, are you?
No, this is just a normal. This is a standard Linux. This is a Ubuntu 2204 LTS, right out of off of the download distro, and it's. I mean, I don't know, Phil. If you're missing any samples. I mean, again, the next step for us together is for me to get some status information from you, or perhaps you already have it, but in terms of things like AGC levels and error reporting that you can detect if you've lost samples or something, would be good for me to log. At the moment, I do that for Kiwis. I have logging of the statistics the Kiwi reports, but I don't have it from you yet, and that's probably because I haven't asked you how to do it.
If you're not actually listening to the audio in real time, and you're not, then the only thing that could happen is that the data out of the USB device overruns its buffer, and I don't know how to detect that right now.
Yeah, well, it seems like you could maybe count the number of samples over a longer period of time and see if you've missed any.
That's
You know,
not
you wouldn't.
correct, yeah.
Okay, so given that if you know the exact, the clock rate of the device.
This is actually a question for Franco, since he knows the USB better than I do. If he could
Yeah.
find a way to have it tell you if there's been overruns.
Yeah. The other thing I'm trying to do is I have an Orange Pi here, to which I've connected a second 888. But as we learned last week that there's some USB 3 error that the driver is reporting to your software. So I was going to ask Franco if he could look at that, because it would be this Think Center. I get these refurbished. Its steady state power consumption is 20 watts. And when the Whisper Demon, the decoders fire up every two minutes, and then it goes to 100% CPU for the duration of those decode jobs, and the power consumption goes up to 40 watts. So that's a lot of power by many site standards. So it would be good to find a lower power host, and the Orange Pi seems like a candidate, but I can't the 888 doesn't work with it yet. So so anyway, that's
well,
but
you don't have to do your processing on the same machine that has the 888. So if the problem is if somehow the CPU is cheaper for processing, you can run that on a machine that's not fast enough to handle the 888 in real time.
Well, this works just fine. I'm doing all 15 channels. It's all 15 channels, 15 bands of Whisper, 2200 through 10 meters are being handled fine.
Have you figured out yet why we're hearing better with my receiver than with the Kiwi? Any clue on that?
Only at KFS, and that suggests that there's some problem with the RF field. Yeah, the spot counts are just about identical at WA2TP and at OH9 GHV. The spot counts are the same between the Kiwis. So that suggests that there's something wrong with probably the signal level feeds to the Kiwis or something are not, we're not giving the Kiwis.
Do you have a noise figure measure on the RX888?
The one I got from Glenn was he thought it was, about minus 152 dBm and 1 hertz. So it's, that's a 20 dB noise figure. Pretty.
Should be better than that.
Yeah,
it
that doesn't sound right.
Well,
it's
the VGA, the variable gain amplifier in the 888 has a variable noise figure depending on gain, but it bottoms out at around 8 dB. At maximum gain. It's almost there at 10 dB, which is where I'm setting it now.
Yeah, so if it's at 8 and Kiwi's at 17, that would explain why you're.
Yeah. Now, on the other hand, this chip is probably running a lot hotter than it's supposed to.
Yeah. Well, I think Glenn is the one who's been making the noise measure figure. I thought you were going to do some of that.
I just haven't done it yet. I've been so busy writing code. I haven't even plugged in the signal generator I got last week.
Another of my colleagues, our colleagues in the Whisper Demon group, Gwen, G3ZIL, supplied a noise notch. I forget the name of this
the noise generator.
Yeah, it's a noise generator, but it has a notch in it, right? That allows you to. There's a measurement of SDRs where you notch out a particular bandwidth and you measure how much noise actually shows up in there. How it's an index of the quality of the ADD.
That's what he's working on. The one he sent me is just a broadband noise generator.
I thought he had a notched one for you.
No. Just so you have it for reference, we use a lot of advanced receiver research HF preamps. They have 20 dB gain and a noise figure of 2.5.
Yeah,
so if you put that in front of it and then set your internal gain appropriately, you're probably going to get a lot cleaner signal.
Yeah, well, that's at KPH. I have an LNA with a 2D. Well, it's like a 2 dB noise figure. It uses the Galley 74s. you know,
Yeah,
that's
well,
what
this,
you-
this is
where
just
you're gonna-
using a standard, well, it's basically yeah, standard transistor, high power. So it's running a very high current, and keeping the noise figure down.
yeah.
But, yeah,
It-
you know, for, HF, you don't need that good a noise figure
It's up to
because
us.
the
depends-
coax is so
Where
high.
your shelving filter comes in. I think you really
Yeah.
need that.
It depends how quiet your site is. And if,
Right,
and
but-
most,
But a
if-
17 dB input is pretty noisy.
it's pretty noisy. So that's why everybody who's, you know, all the Whisper Demon users over the last 3 or 4 years all end up putting LNAs ahead of the Kiwis. And
Right.
then,
That's
and
my
then you
point.
have, then you have an overloading problem.
Well, but not if you
and
get
then
to
you put-
set the
then you put-
gain
then-
right and you have some filtering where you need it.
Yeah, well, then you have to add the filtering, and that shelving filter has proved to be very useful because of the, you know, the ITU noise measurement standard shows that the ionospheric noise goes up by about 26 dB per decade. So your needed noise figure goes down by that amount. But at 10 meters through 20 meters, you need especially at 10 meters, you know, the quiet rural sites have, excuse me a second, I may need to take this call. I'll be right back.
I need to drop out here myself. So 73 all.
Yes, it is.
Yeah, I've learned that on HF, it's a very different beast than
Yes, I am,
VHF
but
and
I'm
UHF when
taking
it comes
a
to
half
noise
hour, so
figures.
Okay, thank you.
So Phil, are you updating your code on this site that Rob was talking about earlier?
I have my own Git repository. Right now, I'm the only one making changes to it. I need to learn more about how Git works. It's KE9Q/KE9Q radio.
Yeah, it's so if you install my Whisper Daemon software, I pull a copy of his code and compile it, pull it out.
Oh, good.
And
Okay.
so if you install Whisper Daemon, you will get a complete working, you know, Whisper. And of course, you can listen to other, you know, other things than the Whisper signals. But the Whisper Daemon will install and configure Phil's code.
At your request, I changed the default TTL to 0. If you want it to be anything else, you now have to explicitly state it.
That's a good thing. One of the problems that we encountered in beta testing was that Phil uses multicast, and if the multicast get outside of the go out the Ethernet cable, then they have to go to a multicast aware switch, or they can you know, disrupt the operation of the network they're attached to.
Well, not always, but especially if you have a low-end Wi-Fi base station, that's the real problem.
Yeah, if there's Wi-Fi there, you're really, and I had, WA2TP, for example, had his Whisper Daemon computer with the RX-888, had a Wi-Fi connection to his router. So the whole thing was unusable until I set TTL to 0, because he was pumping, his computer was pumping out. It wasn't just, you know, the access point in his house. It was the computer itself. So anyway, TTL 0, I think is the right thing.
This is why you test. This is why you test.
Yeah. So, but the installation goes extremely cleanly and easily. I'm you know, Phil, the installation is very clean.
Thank you.
And so I've had no compile errors on, but of course I'm only doing, well, I've done it on 2 platforms. I've run it, I've built and installed it on the Orange Pi with Ubuntu, but that's an ARM-based processor, and on the on the i5s, the Ubuntu 22. But so I only test on Ubuntu 22.04 LTS.
I routinely compile and run this on Debian Linux and Raspberry Pi OS, although, you know, the Raspberry Pi can't handle the AAA. It does handle the AirSpy. And I
Yeah.
also compile most of the stuff on Mac OS because that's my laptop, although I don't actually run Radio D there. I do run the interface tools there, but not Radio D itself.
Yeah, I started out running Wisp Daemon on my Mac OS, and I just all the library dependencies and everything that I
Yeah.
have, and it's not just me; it's all the utilities like WSJTX, and it changes its dependencies. So the issue, it's just trying to debug all the dependency issues, make it a pain to support more than a couple of operating system environments.
Yeah.
So
Dependencies
haven't-
are okay if they're handled automatically, but when they're not, oh boy.
yeah. So I spend, after I get all the code done, then when it gets out to beta, most of the problems are installation and configuration problems, not runtime. So, but I feel like I can go on to I can work on. Well, I wanted to talk, to discuss with you AGC and other status reporting. So
Yeah, at some point.
And you remember that modification you were going to put out on one of your utilities, so I could parse the individual lines of the status.
Oh, yeah, I think
string.
I already did that.
Okay. I'll have to look for it.
But I know I need to document it. I know if you haven't documented, it didn't happen. I know.
Sometimes, yeah. So anyway, Jonathan is been, and I don't know if he's still with us, but he's been trying to figure out how to use, get the system he's using on the VLF stuff to work with it. I don't, he has I think the VLF world has its own hardware and software environments that seem to be somewhat different than we're used to. They don't have audio inputs and outputs. They seem to record and play back WAV files, transmit WAV files and receive to WAV files. So there's that's
Well, why not? They're using audio pretty much.
Well, yeah, I know, but it's but it means it's a different world. It doesn't, so JTX records and playbacks to WAV files, but it's hidden pretty much internally from the outside world that's how it's working. So anyway,
yeah, I'm here.
Okay.
Basically how it works is that that the VLF receiver is fed into the sound card of the VLF capture system, and the software will record the whole spectrum. And so for purposes of amateur reception, EBNOT and FST4W and whisper modes, what you basically do is the software that I use, VLFRX tools, it's very similar to K9Q radio. It's a full digital signal processing suite using simple utilities. So in the end, what I end up with is spectrum data centered at 8.27 kilohertz, and and I filter it to 3 kilohertz wide. So then,
okay, Jonathan, can I ask you a question? You have a receiver that outputs baseband audio. Is that's the original source, and that's going into a device. So there is baseband audio that is the original source of what you're dealing with. Is that correct?
Well, it technically, but it's more like it's more like spectrum data rather than what you consider it audio. It is audio, of course, but for purposes of signal processing, it's the VLF spectrum capture.
Well, what would if you record? I mean, what's coming out of your receiver? If you hook it up to your headphone, what do you hear?
I would hear the VLF spectrum as it is.
The raw 0 to whatever
Yeah.
10 kilohertz.
But you'll mainly hear 60 hertz hum, right?
but
Yes.
yeah,
Yes.
so rather than I'm just wondering whether that in essence what you really want to do is, of course, you don't have a carrier there, so how do you you would need to be that you'd need a BFO. It seems like I'm just wondering whether what if you can simplify the receive chain. I'm wondering if there might be a way to simplify the receive chain, and instead of once you start, munging on the data with your with your software, you now have to have, to some extent.
How could it be any simpler, right? He's got direct sample receiver, right?
Yeah, he has it seems like it. Well, he has a direct sample receiver.
Yeah.
Yeah, so why not? The only thing he needs to do is he needs to shift everything down so that he can, so that 8.2 kilohertz is at produces a 1500 hertz tone.
Easy enough to do.
Yeah, that is exactly what I do. So
you take so if you did that, you have now a continuous stream of audio samples, that are centered, that are coming in at 8.2 kilohertz, 8200 hertz, but are actually been transformed down to the whisper range of 1400 to 1600 hertz.
Yeah.
So if you could transform 8.2 kilohertz to 1500 hertz, you could feed it into WSJTX and it would decode it.
Yeah, and that's exactly what people have done. Here, I could bring up my screen here.
Are people actually transmitting whisper at 8.27 kilohertz?
Yeah, there are a couple people in Europe. They don't do it often. The last time they did it was in March and February. That was their last test.
Well, you got the same problem at VLF that we have at VHF, that there's going to be no transmitters if there are no listeners. So you have to.
Even bigger problem is your noise levels are sky high and your antenna efficiencies are extremely low.
Well, but you've got the FST4W 1800, the 30-minute long.
Well, it doesn't change the physics.
It doesn't change the physics, but it improves your signal noise. Your ability to
deal
pull
with
out.
the signal noise ratio. It doesn't improve it. It just helps you deal with it.
It gives you a narrow receive bandwidth, and as a result, you can.
Well, okay.
We're also transmitting with a lot of power too.
How much actually gets out, I wonder.
I want to bring your attention to the signal processing chain. I'm going to highlight it here. I don't know if you can see it. Can you see the highlighted?
Yeah.
Yes, I sure do.
I don't know what VT read and VT cat are.
Okay,
but I think I can figure it out.
So VT read, VT cat, VT mix, those are all utilities in VLF RX tools. So what it does is VLF spectrum data is recorded to a data store that's raw.
Spectrum data or PCM samples? I don't understand. Time domain or frequency domain?
Well, it's PCM samples.
Time domain. Okay.
Yeah. But it's also time stamped as well, and the samples are aligned to GPS.
Okay, that's good. All right.
So it's recorded in this data store, and you put in your time stamp and the length of time that you want. So VT mix, it will.
Frequency shift, huh?
Well,
what does VT cat do? So
VT cat, the VT cat /P, what that does is that will smooth over breaks in the data. So for example, if the sound card had a little hiccup or the GPS had a hiccup and there was no data, it would actually insert blank data in there. And it wouldn't be just a regular break. That's what the -P does. VT Mix mixes with his loops. So he has some loop antennas. So what he's doing is he's steering his VLF loops in the direction of the signal. That's what VT Mix does. VT Mult, that is the product detector. Basically, is it'll down mix the it'll inject this 6.66 kHz tone and down mix it, and then VT Mix, it will recombine that into the channel. VT Resample samples it to 12 kHz for JT9. VT Filter. So what VT Filter does, it's centered around 1610 hertz with a 2000 hertz wide bandwidth. VT Blank. So Phil, you were talking about noise. VT Blank is a spheric blanker. So what it does is it'll blank out impulses.
Understood.
So and during the summer, this is a big problem because there's tons of spherics in the summer with summertime lightning. So based on these settings, it will blank it out. It's not perfect, but it does decrease the noise for quite a bit. VT Raw converts the VT file format, the stream into wave data, and it adds a gain factor of 100. And then you have this wave file right here. And then you feed it into JT9.
Okay.
So you feed it into JT9 with these options here. And then this is the decode result.
Cool.
That's good.
All right.
So that is an example of FST4W on VLF. The other amateur mode that I'm excited about is the EBNOT mode, which is a coherent BPSK mode over VLF, and it also works on LF as well.
Where can I get VLF tools? I don't get a hit for it in Google.
It's VLF RX tools. So VLF RX dash tools. It has a very long and comprehensive documentation page. It's not always completely intuitive how to put a system together. But over time, I've kind of learned how to use it. And so I have a running system right now. I'm working on the 3-channel system currently. But what it does is it'll read data from a sound card and it'll GPS timestamp it. It'll filter out 60 hertz. It will resample to any sampling rate that you need. It'll detect whistles and chorus. It'll do time of group arrival lightning location. It monitors Navy VLF transmitters. There's a bunch of signal processing tools, plotting programs. It's quite comprehensive. And you can also, so I capture the signal on a Raspberry Pi. I also send that spectrum compressed, Vorbis compressed over the internet to a server that's run by the author of VLF-RX tools. So he runs an event detector and a couple other things. It measures the noise floor and plots one of the alpha frequencies. And I also send the spectrum to a VLF server that I plan on installing Whisper Demon. So from there, so you could have you could record this VLF spectrum, you could store it to disk or send it over a network real time, a local network or the internet. I think it uses only about 300K of upload if you want to send a full 48 kilohertz stream. So you could have like multiple systems, multiple VLF systems capturing data and then sending time of group arrival data to a central server for lightning location. So there's tons and tons of different things you can do with it. There's a lightning location network being run right now. The Indian lightning location, the Indian lightning detection network. And there's a bunch of other projects as well. So it's really cool to mess around with. And I've been messing around with it for many years, at least since 2014.
Okay.
So, oh, and Phil, I emailed you a while ago. I think this was back in like beginning of June. We were talking about the power grid. There was a lightning strike to the UK power grid. So the author of VLFRX tools, he used his software to plot frequency. He found the time when there was the dip in frequency when lightning hit the grid and there was much more load on the grid, and then he was able to locate the probable spheric based on the time that the load on the grid started. I sent you that email back in June, I think.
Yeah,
That
I
was
still remember it, but in June I was in Germany.
Yeah, it's there if
yeah,
you search.
yeah.
If you just search my call sign KC3EUY, I'm sure you'll find it. But yeah, that was me that emailed you. So I kind of give a rundown of VLFRX tools, links and documentation, and the utility programs that are running on my system right now.
Okay. You sent to me in KC3EEY. What is your email address?
EMUMAN100@gmail.com.
Okay, I found it. Yeah, and I see I have tagged a message for response you just sent me on the 18th. Sorry about that.
No, that's okay. I actually wanted you, because I actually wanted you to take a look at VLFRX tools and maybe start playing around with it or at least just see what it's about, because I figured you could probably add some really cool input. There's an active VLF community on groups.io, which I'm a member of, and so is the author of VLFRX tools. So we talk about all different sorts of things. People use Spectrum Lab in Windows often for VLF stuff, and I think that's how they did the first FST4W reception. Not sure how they did the transmission, but yeah, there's an active community, and that email was just kind of a basic rundown of what I was doing.
Okay.
But yeah, that was me.
All right. Well, I'm building it right now. Let's see. Got all the dependencies installed. It's compiling.
It builds on Linux, it builds on Mac OS and FreeBSD. I even got it to build on Solaris. That took a little work, but I did get it to build.
And it's installed. Now, are there manual pages?
No, but there is
Aha.
a single documentation page. Oh, and there's also, if you look on the documentation page, there's a test script where you would run that test script and it will test all of the utilities to make sure that they're built properly. I think it's test_all or something like that.
Okay. Test. Okay, there's a run all, test all, something like that. All passing so far.
I think there's like 9 tests. It's fairly comprehensive.
Yeah.
On FreeBSD, the utility to program or to calculate geographical calculations, that fails on FreeBSD. I don't know why. I think it's because of it's mainly it's written on Linux, so he uses a lot of like you know.
There might be slight differences in the math libraries. I know of a few.
Yeah, and there's also like for one of the utilities he uses, getopt. Getopt is different in BSD and Linux.
Yeah. Okay. All the test pass.
Yeah.
Okay. I
Yeah,
just
so
have little man pages. That's all.
Yeah, he doesn't have man pages, but he has.
I see the notes. Yeah.
Yeah. Yeah, it's really fun to play with. And one of the things that I really like about this is that you can use a GPS pulse per second fed into your sound card, and you can get time stamping accuracy in the hundreds of nanoseconds.
Well, whatever the sample rate is of the sound card.
Yeah.
Yeah, I've been thinking about using that trick with our HF radios.
Yeah, definitely read the timing section of the documentation.
Yeah. Okay. He's actually, this looks reminiscent not of my stuff, but of what's the package of tools where you pipe together various signal processing elements, SD something, SDR. Discovered it a couple weeks ago. Forget what it was
Not
called.
sure.
TSDR.
That's it. That's it.
Oh.
That's it. Yeah. It's reminiscent of that.
Yeah.
Yeah, I always thought this is a good way to do a basic DSP signal toolkit.
Mm-hmm.
Radio is too elaborate.
Yeah, this actually works very well. You could pipe directly, or you could use named buffers.
Yeah, this is the kind of stuff you want for batch processing after the fact. My stuff is it's a different tool. It's for real time.
Right.
Perception.
Well, so the VT card utility, that's run in real time. That has to be run as root. But everything else is doesn't have to be run in real time. It's only VT card.
Yeah, I understand. Yeah, but something has to capture the data, but then the rest of it can be processed in batch format.
Right. Yeah, in the documentation, it actually tells you to run VT card as root, so it could capture real time.
Yeah, it's pretty cool.
Yeah, I could share my my terminal.
Okay. I'm looking at the notes page right now. It's pretty comprehensive.
Yeah. I hope that this doesn't take over your screen. I'm just going to share my so these are the this is what's running on my Raspberry Pi right now. So we have VT card. It's capturing using the also driver. VT time handles the GPS time stamping. VT filter, that TH equals 5. That's the tracking filter, the mains tracking filter threshold. 5 is for
Oh, one question here. It looks like they're using the card at like 96 kilohertz sample rates. Do sound cards really go that high? I know they sample that high, but do they actually reproduce signals that high?
Oh yeah.
I mean, the input circuits are not low past it.
Well, so there's actually some roll off, but I could show you. I could show you with
96 kilohertz or 192 kilohertz for hi-fi audio is a gimmick, right? It's pointless. But if the cards can actually do that, then they're useful to us hams for other things besides hi-fi audio.
Well, here I could show you because sometimes the input circuitry can actually limit that bandwidth, but on the sound card that I use, it doesn't really limit it all that much. It's just a coupling capacitor, and I could show you a real-time spectrum display of the bandwidth if this thing will ever work. Takes a while to log in, but yeah, so I capture up to 48 kilohertz. So in the spectrum display, you could see NAA and all the.
Okay, all right. Well, if you're sampling 96, you're going up to 48. You can't do any better.
Yeah.
Although, I mean, you're probably getting some aliasing because no filters, analog filters can be that sharp, but
right. Yeah, and you know, you don't have to run this on a Raspberry Pi. You could run this on a regular computer.
I know, yeah.
So what Paul does is he uses a one of those 192 kilohertz audio interfaces, hi-fi audio interfaces, and that actually works quite well for him.
Yeah.
And he's able to capture like VT spec. And for oh, there we go. And for filtered or for your for a lot of your applications, it's 10 hertz. There we go. For a lot of your applications anyway, you're using within in the audio range. Here, So this is a real-time spectrum display of the VLF spectrum. You could see 24, the peak at 24 kilohertz and 24.8.
Where are you?
Northeastern Pennsylvania.
All right, that explains that.
Yeah. You could see the peak at 40.8 and
Yeah.
37. So those are your Navy VLF transmitters.
Yeah.
It's bobbing up and down. It's actually quite noisy because of summer lightning. You could see
Okay, now what's that one at below a 38? What is that? 37 something.
that is, I think that's Iceland. NRK.
I was just wondering if you're seeing images. I mean, how good is the low pass filtering on your card?
Yeah, no. It those aren't images. No, that's NRK.
That's real. Okay.
Yeah. It does get a little sketchy.
What antenna are you using? A loop of some kind?
It's a probe antenna. It's a
Oh, okay.
um
Oh, you're using the Earth as your antenna. Got it.
Yep. And yeah, you can see, and you know what's also really cool. So around 2 kilohertz, you can see that little dip. That's the attenuation from the Earth ionosphere waveguide.
Oh.
Because around 2 to 4 kilohertz, there's quite a bit of attenuation.
Oh.
Those are around 1.7 and 3.4 are the resonant modes of the Earth ionosphere waveguide, and it's at those frequencies that there's often a lot of attenuation from spherics.
Think about this. That's just it, the Earth. Oh, it's just a waveguide. It's a very big waveguide.
Yeah.
Okay. Cool.
And there's so if you wanted to investigate that further, there's the program used to monitor Navy transmitters. It can also monitor the whole spectrum and create a compressed spectrogram.
Yeah.
And it will allow you to actually look at a spectrogram in like a whole day, and then you could actually see the change in that attenuation over the diurnal.
It's interesting is how stable those transmitters are.
Oh yeah.
Here's a question for you. If you had a really narrow filter at 50 hertz, would you see anything?
A narrow filter at 50 hertz.
Yeah. Could you pick up 50 hertz from a European power grid, for example, outside North America?
Yeah.
You can?
Yeah.
Oh.
It'll be very faint, but yeah.
Of course, there are more than one, and they're going to be not in phase. Slightly different frequencies.
Right.
Wonder how many you'll see.
Well, I believe, at least with the antenna and the preamp that I'm using now, I would just see a very, very weak 50 hertz.
You couldn't tell anything else about it.
No.
Hmm.
Now, and also people in Europe, they also detect a very weak 60 hertz.
Okay. Well, that's cool.
Yeah. But
of course, in Europe, they would probably see several different ones. Well, they're probably not that far off from frequency, but they're not synchronous. I mean, the Western Europe continent is synchronous and the UK is separate.
Right.
Well, in the US, we have 3 grids
Yeah.
that are not synchronous. Of course, you could monitor them. In fact, there are sites that monitor the local power grids and report them online with GPS timestamps. In fact, you can see animations of various grid events.
Can
I
you
forget
put,
the name of that site.
yeah, put that link in the chat.
It's on YouTube, but I've forgotten. I think I subscribed to it. See if I still do. And it's kind of cool. It can automatically tell when a generator failed or when a load was dropped.
Yeah.
And you can tell from where, because it doesn't change instantly around the grid. It moves in a wave.
Oh, yeah. Yeah.
Find it was a long time ago that I grabbed this. Can't find it. I don't know if I have it under this description or not.
So with a system like this, you can do power grid studies.
Yeah.
I actually have 60 and 180 hertz being monitored. So I could create I could create a plots of those at any time. Let's see if I could.
I can't remember the name of that channel. I thought I subscribed to it, but no, I'm just getting lots of other hits. I always thought you could watch the power grid yourself, and if the frequency deviates right before a blackout, it's a big one.
Yeah. Yeah, that's what Paul saw the one time.
Well, the famous one is WABC in New York in the 1965 blackout.
Yeah.
The DJ was wondering how the electricity could be slowing down. Turntables are slowing down. Well, now we have automatic low frequency trips.
Yeah.
But they didn't then. Yeah, anyway, I can't find it right now.
Here's another. This is not related, but this is the performance of the timing system. So you can see the top plot. That's the pulse.
Oh, you're working out your sample clock by looking at 1 PPS.
Yep. Yep.
See it? Yeah.
Yeah, this is the performance of it, and it's interesting because it seems like that that the sample rate seems to follow Nathaniel's air conditioner.
Oh, it easily could.
Yeah, because this sample rate, I believe, well, it's obviously very temperature dependent because of the
Sure.
crystal on the sound card, and you can see the variations throughout throughout the night, and then when
When he
Nathaniel
leaves, he turns it off. Yeah.
yeah, he so so around 1600 UT, I think that's when he turns on his air conditioner. But yeah, this is just
Okay. Well, ovenized crystals work.
yeah. And I keep this whole thing in an enclosure, and the temperature is kept fairly stable, but it doesn't vary all that much where it's a big issue.
Yeah.
But yeah, and there's oh, I wanted to get that that plot from so with this software you could do like a lot of
Yeah. Anyway, it looks cool. I've gotten it installed, but I got to go right now.
okay, yeah, well, if you have any questions,
Yeah.
you know, shoot me an email.
Okay, so yeah, Jonathan, if you need some help with, getting whatever you have, I can walk you through it.
Okay. Yeah.
Basically, we need to, if you installed Whisper Daemon on your Pi, and I would configure it for a 8 kilohertz band channel, which is a one-line change. Then we
I'll see you
configure
guys.
see it, Phil. And then I could do all this remotely once you get with Whisper Daemon set up. And then you would have to copy your WAV files as they came in. You'd need to copy them into a particular directory on the Pi.
Yeah, I can do
so
that.
Whisper Daemon just sits there and looks for new files to appear. Ooh, except the way it works right now is it's looking for 1 minute long WAV files. So if you had a 30-minute WAV file, you might need to chop it up into 31-minute logs and just copy them in.
I could set any sort of granularity that I.
Yeah, well, if you can use socks to chop it up, if you wanted, and create it, if you have a 30-minute long, it starts on minute 0 or minute 30.
Right.
Then you copy those 30 files, WAV files, into a directory, and Whisper Daemon that would pick those up and run them through the 4W, the JT9 decoder, and would queue them and upload them to WhisperNet. And so that's really what you need to do to receive.
Yeah, I could, so I can set it to generate minute long WAV files in a particular directory.
Yep, that's if you did that, then the Whisper Daemon doesn't really care where the WAV files come from. Just as long as they need to be 12 kilosamples, and they've, I think I look a little bit at the header, make sure that it's that it's 12 kilosamples. I may do a little validation on the WAV file header, but there's not much.
Are you looking for a specific file name in those WAV files, or does it matter?
Yeah, yes, there is a format that that I look for, and yeah, you can see an example of it if once you get Whisper Daemon set up. I'll give you an example of the file format. Basically, it's a year, month, date, underscore. I don't know. Here's I'll give you an example of some. Let's see, where am I looking? I got so many. Okay, here, I'm going to show you an example of where it goes.
Okay.
Hold on, here it comes. Okay, so this is the home directory of Whisper Daemon. So the user Whisper Daemon, and all the Whisper Daemon records all of its into a temp, RAM disk file system. So it's in dev shared memory subdirectory. So if I can go over there, and then there's under this is recordings, and then there's the let's see what's yeah, here's a K9Q, K9Q. Let's see, what am I doing? 0, I guess. And then there's 160. Okay, so this is the receiver, and I would give you a receiver name. We just configure it, and then you can let's see. Sorry, that was it's nothing happening there. It's not. I'm not decoding. Let me go someplace else where I know that things are running. I'm not sure that. Here's so if you do a watch, you can watch. You see, these are there's the WAV file name format. So this is some kind of POSIX derived name, which is year 2023, month 8. This is UTC, day 1. T for I guess separates a date from time. This is the hours, minutes, seconds.
I don't think I'm seeing what you're.
I'm sorry. I switched to a different window. Sorry. Let me move this. I'm sorry. Let's see. There. See, there we are. Let me make. Okay, so this is over on a different machine, but you can. We're in this directory.
Right.
Okay, which is, a recording directory. This is the name of the receiver. It's an Omni C receiver. That's an antenna that it's listening to. And this is 20 meters. So we're listening. So this is wave files that are off of 20 meters. And you can see the wave files growing. The topmost one is growing.
Yeah. Yeah.
So each one of these is a minute long, or approximately a minute long. And the format of the file names, the format of the file names, if you look at the format, you can see it's 2023 0801 month date, T, capital T, and then it's the 03 hour 03 minute 49 second 0 Z, and then it's underscore frequency in hertz underscore modulation format dot wave.
Okay. The modulation would be
It expects, this is what would come out of a transceiver tuned to a whisper frequency. So
right.
So it's going to be upper sideband, so that the audio is expected to be in the range of 1400 to 1600 hertz. So your 8200, your example that you showed us, you were taking 1600 hertz or something. I forget. It was you were using a different band for 80. You were transforming 8200 to something else more like 2K or 1800 hertz or something.
Mhm.
So you'd want the 8200, if that's, you know, the near, to be to appear as a 1600 hertz tone. If you were listening to an 8200 hertz, if that's your band, you know.
Yeah.
This will search plus or minus 100 hertz of there. So you could you don't center exactly on the transmit frequency.
Right.
You can just center on the nearest 100 hertz. So if you, and if it's 8223, you know, take 8200 as it, you know, as it would go to 1500. So the signal would come out at 1523 hertz.
Yeah. Yeah.
In the wave file. Does that make sense?
Mm-hmm. Yeah. Yeah. I know how to format it now. Now I would imagine how I could test it. I could get a known. I could take spectrum from a known transmission date and run it through my signal processing chain, and then run it through JT9.
Yeah.
And so now with this file format, do you have different options for modulation, or is it just upper sideband?
No, the JT9 and Whisper Demon only accept 12 kilohertz PC 16-bit PCM as the input file format. So.
Oh, no. I mean, you know, for the purposes of this file name.
Oh, the file name. No, no, I extract, if I'm going to, I use this information in here to, it ends up propagating to the whispernet.org when we upload the spots. So you really do need to follow this file name convention in order for them to be the spots to be formatted properly for upload.
Well, so since I'm not using upper sideband,
you're going to be, you are in effect, if 8200 shows up as a 1500 hertz tone, you're in effect upper sideband. That's we're just looking for audio tones in the range. These wave files should contain audio tones in the range of 1400 to 1600 hertz.
right? Yeah, but it's not technically.
It's not you're not technically upper sideband. That doesn't make it doesn't. So I really don't care how you generated the wave file, where it came from originally. That's the upper sideband is immaterial. If
all right, so well, for purposes of file naming and reporting the right spot data, instead of _USB, what should I name it?
Well, these are going to get deleted, so just put in _USB. It won't make any difference to me. It won't affect.
Okay.
So just call it a USB, even though it isn't really coming from an upper sideband. Just put in USB.
Now, I'm gonna have to write a script to generate these file names, because so that's the only challenge right now, is that I have to figure out a script.
Well, it'll be a single printf statement. You can use printf to generate this. So if you have a bash variable with the names, use your names and just show me the names that you have. Are you going to have? You're going to have all the information that's in these file names. Do you have that information available?
Well, so what I have in the file names right now is year, month, day, dash, hour, minute, second.
Okay, well, that's fine. It's just, I mean, I can do that. I can write you the one-line statement that it takes to transform that. I just need to see your file format, your file naming format. No. So,
Okay, I will email that. I will email that to you.
yeah, just the thing to do is to start by downloading Whisper Daemon, and then I'll send you the information to give me remote access. And once I do that, then I can look at your files as they appear in this directory, in a directory. You show, if you can copy them in using your naming convention, and I'll take care of dealing with your naming convention as they are now.
Oh, perfect. Okay. All right. Yeah. And then that'll be like what you'd call, like the VLFRX tools receiver, something like that.
Yeah.
Okay.
But the idea is that you would start up Whisper Daemon. I'll configure it for you. I'll tell you where you put your files. Okay. And then you should start up your code and start putting files into this directory.
Okay.
That I name, and I'll take care of assembling them into and decoding them, and I'll delete the files once I'm done with decoding them. So once they've been processed by JT9, does that make sense?
Yep. Yeah.
Okay, I mean, it's a 30 minutes of WAV file is about 48 megabytes. So it's so what happens is that that you accumulate 30 1-minute WAV files. Whisper Daemon concatenates them all together, creates a 30-minute WAV file, runs the decoder, and then it deletes single 30-minute. And all of the 1 minutes that went into it gets purged. So you'll see the file system usage go from, 2 megabytes to 96 megabytes, and bam, it'll go back down. So,
okay.
So you don't have to worry about getting rid of the files. You just need to get them into the directory, and I'll take care of the naming. You put them in the names you have, and I'll figure out.
Okay. Yeah, that'll work fine. Yeah, I'll set that up. It's a very easy thing to do, and I'll make a directory for it. And
So yeah, this directory will be created. I'll do that. But so download and install Whisper Daemon. Go to our whisperdaemon.org site, and there's a link to the GitHub page where you get clone the Whisper Daemon package from GitHub.
Okay. All right, I will do that.
And then it'll get to the stage of it'll tell you need to edit your config file. At that point, you want to send me an email, and I'll tell you what to do next.
Okay. All right, sounds good.
Good. Okay.
Yep.
Late for you there on the East Coast. So I
gotta be up at 4. It's a little.
Oh, goodness gracious.
Okay. Little late for me, but yeah.
Okay.
All right. Thank you again, and
Oh, sure.
Contact you soon.
Okay. Bye-bye.
All right. Bye-bye.